On August 30, 2026, humanity is about to launch one of the most ambitious scientific instruments ever built, a space telescope so powerful that in a single day, it could collect more deep space imagery than Hubble gathered throughout its entire 36-year mission. Its field of view is 100 times larger than Hubble's. Over the next 5 years, it will measure light from more than 1 billion galaxies, discover up to 100,000 exoplanets, and collect roughly 20,000 terabytes of scientific data. No telescope in history has attempted anything on this scale. Its name is the Nancy Grace Roman Space Telescope, and it may fundamentally change our understanding of the universe. But to understand why Roman matters, we first need to understand the telescope it was built to surpass, Hubble. Launched in 1990, Hubble became one of the most successful scientific instruments ever created. Over more than 3 decades, it helped determine the age of the universe, revealed galaxies forming shortly after the Big Bang, uncovered supermassive black holes at the centers of galaxies, and captured planetary systems in the process of formation. In many ways, our mental image of the cosmos comes directly from Hubble. But Hubble has one fundamental limitation. Its field of view is tiny. Imagine stretching out your arm and holding a grain of sand at your fingertips. The patch of sky covered by that grain is roughly what Hubble sees in a typical deep space image. Its precision is extraordinary, but that's also the problem. Trying to map the universe with Hubble is like surveying an entire continent through a drinking straw. You can see incredible detail, but only one tiny piece at a time. Every observation is like adding a single tile to a puzzle containing billions of pieces. The picture grows, but painfully slowly. To answer questions about dark matter, dark energy, and the large-scale structure of the universe, astronomers need to observe enormous portions of the sky. At Hubble's pace, that would take longer than the age of the universe itself. Roman was built to solve that problem. Its wide-field instrument can capture an area of sky 100 times larger than Hubble in a single exposure, while maintaining nearly the same resolution. Hubble-level detail, 100 times the view. That's the leap we're talking about. Before we talk about Roman's discoveries, there's another story worth telling. The telescope is named after Nancy Grace Roman, one of the most influential figures in modern astronomy. Born in 1925, Roman fell in love with astronomy at an early age. In 1959, she became NASA's first chief of astronomy and one of the first women to hold an executive position at the agency. At a time when women were routinely told they couldn't become scientists, Roman ignored the limits others tried to place on her. For decades, she fought for a revolutionary idea: place telescopes above Earth's atmosphere. Long before Hubble's first mirror was polished, Roman was securing funding, navigating bureaucracy, and defending the project. Many historians consider her one of the key figures responsible for making Hubble possible. She passed away in 2018, but the telescope she championed transformed our understanding of the cosmos. Now, the observatory that bears her name is preparing to take the next step. Here's one of the strangest facts in science. Everything humanity has ever seen in space, every star, planet, galaxy, nebula, and black hole, accounts for only about 5% of the universe. The remaining 95% is invisible. We know it exists only through its effects on the cosmos. About 27% appears to be dark matter. It doesn't emit light, reflect light, or interact with ordinary matter in ways we can easily detect. Yet, its gravity holds galaxies together. Without dark matter, many galaxies should simply fly apart. It acts like an invisible framework supporting the large-scale structure of the universe, and we still don't know what it is. The remaining 68% is even stranger: dark energy. In 1998, astronomers discovered that the expansion of the universe isn't slowing down, it's accelerating. Something is pushing galaxies apart faster and faster. That discovery earned the 2011 Nobel Prize in Physics, yet no one knows what dark energy actually is. Roman's primary mission is to investigate both mysteries. By mapping hundreds of millions of galaxies across billions of light years and measuring how cosmic expansion changes over time, Roman will provide the most detailed picture ever assembled of how dark matter and dark energy shape the universe. If any telescope can help solve the mystery of the missing 95%, it may be this one. Because for all our technological progress, humanity still doesn't know what most of the universe is made of. That's an astonishing thing to admit, and Roman was designed to change that. Dark matter and dark energy may be Roman's headline mission, but they aren't the only things it will search for. Roman will use a technique called gravitational microlensing to discover planets beyond our solar system. When a planet passes in front of a distant background star, its gravity briefly bends and magnifies the star's light. This creates a distinctive pattern that astronomers can detect. By monitoring hundreds of millions of stars simultaneously, Roman is expected to discover more than 1,000 exoplanets through microlensing alone. Combined with other detection methods, the mission could identify as many as 100,000 new worlds. For comparison, humanity has confirmed only about 5,700 exoplanets in total. Roman is especially sensitive to worlds that other methods often miss, including small planets, distant planets, and even rogue planets drifting alone through interstellar space. Among those 100,000 worlds will almost certainly be some of the most promising targets in the search for life. Roman won't detect life directly, but it will provide future observatories with decades worth of targets. Roman will launch aboard a SpaceX Falcon Heavy rocket from Kennedy Space Center in Florida. Its destination is the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth. The James Webb Space Telescope already operates there. After a few weeks of testing and calibration, Roman will begin scanning the sky with wide-field infrared surveys. Its mission is simple: build the largest and most detailed map of the universe ever created. By the end of its primary mission, Roman is expected to collect up to 20,000 terabytes of data. The archive will be so vast that extracting discoveries from it will depend heavily on artificial intelligence and machine learning. Some of Roman's most important discoveries may emerge decades after the telescope itself stops transmitting. Roman won't be working alone. It will work alongside the James Webb Space Telescope. Webb can observe tiny regions of space in extraordinary detail. Roman can scan enormous areas at Hubble-like resolution. Together, they're like a camera equipped with both a telephoto lens and an ultra-wide lens. Roman finds the targets. Webb investigates them in extraordinary detail. Together, they form the most powerful space-observing partnership humanity has ever built. For more than 30 decades, Hubble transformed our understanding of the cosmos. It revealed the age of the universe, the formation of galaxies, black holes hidden at galactic centers, and planetary systems being born around distant stars. And did all of that while observing through a field of view no larger than a grain of sand held at arm's length. Roman's field of view is 100 times larger, and launch is just weeks away. One scientist involved with the mission once said, "If Roman wins a Nobel Prize, it'll probably be for something we haven't even thought to ask about yet." That's what happens when you build an instrument powerful enough to see things no one has ever seen before. For 13.8 billion years, the universe has guarded its secrets. Roman is about to survey 1 billion galaxies in search of answers. 1 billion galaxies, each containing millions or even billions of stars. More cosmic real estate than any telescope has ever explored. And somewhere within that vastness may be discoveries that completely rewrite our understanding of reality. From Nancy Grace Roman looking up at the night sky in an era that discouraged women from becoming scientists, to the telescope that now bears her name, humanity has never stopped pushing into the unknown. We may not be able to see 95% of the universe, but we never stopped looking. And that may be the most remarkable thing about our species.